Oh, hi there, team. Thanks so much for showing up for your math learning. It's Tutor Grant, and we're going to look at some of the skills that are going to show up as the new topic on this weekend's Math Mastery League. So I've got my Delta Math ready. I'm just going to go in and look at some exponent rules, variables, and coefficients. Let me just get the this organized here. There we go. Okay, so when I have something like 2m to the 3, then you have your scratch paper out, so you have 2m to the 3. The rule here is this is the same thing as the brackets multiplied 3 times. So that is to say this is 2 to the 3, m to the 3, in other words 8m to the 3. These ones are easier, but they're going to get you started. 8m to the 3. Okay, there we go. What? Did I write 8m to the 8? Why did I do that? Anyway, so you get to do all kinds of stuff like that and perplex yourself. Why did I type 8m to the 8 when I knew perfectly well it was 8m to the 3? Okay, with this one here, you want to be able to very quickly tell yourself and me that you know that 7x to the 5 multiplied by 9x to the 3 is equal to 63, which is 7 times 9, x to the 5 plus 3. In these cases, we add the exponents when we're multiplying these because x to the 5 multiplied by x to the 3 is equal to x times x times x times x times x. That's x to the 5. Okay, that's that one. Multiplied by x times x times x. That's x to the 3. So we have x to the 5 plus 3. So we would proudly write in 63x to the 8. This time it's to the 8. Yay. Okay, and a new one. Okay, so this one is negative 9x to the 7. Okay. All right, and then you just keep practicing, right? This one is 64k to the 3. Oops. 64k to the 3, right? You keep practicing. Okay, this one here. This I want to talk about an example like this. This one happens to be 4d to the 20. What am I saying? It's like the words that are coming out of my mouth that make no sense. Never mind. This is 2d to the 5 raised to the power 2. In this case, you want to tell me quickly that that's 2 squared, or 4. Okay. D to the 5 times 2. So that's d to the 10. Why do we multiply the exponents in this case? Well, if I write this out, 2d to the 5 squared, if I expand it, that's 2d to the 5 multiplied by 2d to the 5. It's been a long day. And then I multiply 2 times 2, that's 4. I multiply d to the 5 times d to the 5, that's d to the 5 plus 5, for that reason up there. Okay, that's d to the 10, or d to the 10. Okay, so you wanna have these skills being very fast because it's cool to have these skills fast. Are there other problem types? Yeah, this one is positive 8c to the 9. This one is 8s to the 6. That's s to the 5 times s to the 1. Don't forget that little s to the 1, it also counts. Okay, this one here is positive 35p to the 7. Okay, so you want to have those very fast. When we get into mixed power problems, there's a little bit more going on, so you may need your scratch paper a little bit more. Okay, so I'll go up here, I've got a little bit of blank. So I copy this down, negative 4x squared y to the 5 multiplied by negative 4x to the 5 y to the 5, okay? And then you want to quickly do like, okay, this is negative 4 times negative 4. You're not going to write this out, but I'm showing you what happens in my head. X to the 2 plus 5, because we add the exponents together in this case. Y to the 5 plus 5, because we add the exponents together in that case. That's positive 16, x to the 7, y to the 10. Very fast. You want to get so fast with these. 16x to the 7, y to the 10. No! And be careful that you don't like write the y as part of the exponent, okay? You just gotta go down, and then you go y to the 10, okay? Yeah, okay. So here's another one. Again, this one is multiply the exponents, but we just have to be so fast at applying the rules. This is negative 2x cubed y squared, all raised to the power 4. So this is equal to negative 2 to the power 4, x to the 3 times 4, y to the 2 times 4. So we proudly write positive 16, because that's 2 to the 4, but even negative still is going to the 4 to an even number. Okay, x to the 12, the y, oh no, go down, y to the 8. Hooray! Okay, let's keep going. These are going to be tricky for you if you do not pay careful attention. Oh my goodness, and I'm not naming names, but in our class today, when I say we, I mean the students made this error several times, which I wholeheartedly approve of because this is a very common error. Okay, 4x to the 5 plus y squared is equal to 4x to the 5 plus y multiplied by itself. And when we multiply a binomial, meaning a two-number thingy, it's got a number thingy there and a number thingy there, so it is a binomial, just like bicycle. Okay, these are two pieces. Okay, when you multiply a binomial times a binomial, this one's got to shake hands with that one. So that gives you 16x to the 10. This one's also got to shake hands with that one. So that gives you plus 4x to the 5y. This one shakes hands with that one. So that's plus 4x to the 5y. And this one shakes hands with that one. So that's plus y squared. And this simplifies to 16x to the 10 plus 8x to the 5y plus y squared. Is there a shortcut? Yes. The shortcut is to memorize this. A plus b all squared is equal to a squared plus 2ab plus b squared. Use that as an identity. There's my a squared piece. This bit squared is that. A times b is 4x to the 5y, so that's this 2ab, that's this piece, 8x to the 5y, because I have two of them. From doing this and doing that, you see two pieces. Okay? And then this bit, y squared, is just that b squared there. Okay, so I'll proudly write that in. Yay! Okay, so that one, same type of problem. This one we've seen, so I want this here. We haven't seen quotient yet, because for some reason it's not in those other problem types. But here you go. If I have 30 over 6, that's just the number 5. X to the 5, y to the 6, divided by x squared, y to the 8. Okay? In these cases, x to the 5 over x squared, this is actually equal to x times x times x times x times x. 5 copies of x multiplying is x to the 5. X squared is like this, x times x. 2 copies of x multiplying. X divided by x is 1, so that cancels. X divided by x is 1, so that cancels. What are we left with? X to the 3. How could we have got there from these numbers? X to the 5 divided by x to the 2 is equal to x to the 5 minus 2. You just subtract the exponents. So if you ever have a general one, x to the a over x to the b, this is x to the a minus b. There's your rule. There's rules for all these, but I think y'all can do that for yourselves. Let's go. So in this case, we subtract the exponents. 30 over 6 is just 5. Okay, x to the 5 over x to the 2 is x to the 3, and y to the 6 over y to the 8 is y to the negative 2, which this program doesn't like because it only wants positive exponents. See that there? Oh, why won't that highlight? Positive exponents only. There, positive exponents. So they don't like this negative exponent. But the negative exponent just means go downstairs. Or if you're downstairs, go upstairs. So we can write this as 5x to the 3 over y squared, like that. 5x to the 3 divided by y squared. Let me just show you. That's how our answer look. Yes, yay, no problem. All right, so that one is 36 x to the 5 y to the 6. 36x to the 5 y to the 6. Like that. Right? You want to get really fast with these. This one is x squared y to the 4. Right? Because I just instantly apply the rules. You want to get to that point where you instantly apply these rules. That way you're swimming. You know, you're super fluent. Okay, so those are mixed power problems. Let's go. Next one, distributive property. We're going to look at these. What time is it here? Yeah, okay, cool. So here, when we have distributive property, we are going to be working on problems like this. So minus 2, 7x squared plus 2. This minus 2 multiplies here and here. So this is minus 14x squared minus 4. Okay, that's just, I'm not going to put that in. This one here, sometimes you're going to have to apply your exponent rules, like 5x times 2 plus 3x. This whole thing multiplies in to give you 10x, and then this thing multiplies here to give you plus 15x squared, because that's x to the 1, that's x to the 1, so we add the exponents, x squared. Okay, that's how these done. Okay, so you just get the chance to distribute a bunch of stuff and practice. I mean, you can do as much as you want. Let's take a look at distributive practice level 2. So this one is 9 times 6 gives us 54. X times x squared gives us x to the 3. And then we're going to add 36, because that's 4 times 9, x. Just get really fast at distributing. Okay, so that one there is triple distribution. We have to make sure we do the multiplication 3 times. This one here, let's do this one. So I notice this is going to be negative 64, because 8 times 8 is 64, but it's negative. X to the 4, because x squared times x squared, I add the exponents, x to the 4. Plus, because negative 3 times negative 8 is plus 24. X to the 3, because I have x squared times x, is x to the 3. Minus 32x squared, okay, so that's that. Yeah. So that's how these do. Okay, it's distributive property. Simplifying by distributing, there's going to be problems like these, where we have to collect all the stuff together and get a simplified polynomial. This is more like what you're going to see. Okay, stuff like that. But I'm going to be devious and give you nasty ones. Well, no, they're not going to be nasty. There may be some fun, interesting stuff, I hope. Okay, 2x plus 5 squared plus 4 times x plus 5 plus 1. Well, that's very interesting. It's got this x plus 5 factor that shows up in a couple places. You can almost common factor that out and do something fancy. But I'm not in the mood for fancy. I'm just simplifying here. So this is going to be equal to 2 times x plus 5 times x plus 5. I mean, I can use the identity and do that, but I'm going to do it step by step. Plus 4x plus 20 plus 1. Okay, so we got some like terms there that are going to cancel. This is equal to 2 times x squared plus 10x plus 25. Okay, when I do all of these, that's 5x, that's the other 5x to make 10x, that's 25, plus 4x plus 21. Okay, and then we've got 2x squared plus 20x plus 4x is 24x. Plus 2 times 25 is 50, plus 21 is plus 71. Okay, let's see if it likes it. Oh, we have 2x squared. Okay, 2x squared plus 24x plus 71. Yay! It's great, eh? Let's do another one. Okay, this one I'll do in my head just to do that in my head. So that's going to be negative, so it's going to be 3x squared. Okay, and then we're going to have minuses, minus 24 minus 27x. And then we're going to have 1648. 12 is 60, 54 plus 54. Yeah, I got it. All right, so you can build your speed here. I'm just going to try and speed run a few of these. X squared plus 2 is x squared. Ooh, well, that's weird. Squared plus, and that's 2x through 6x plus 1 is 5 is 2. Yay! Okay, this one is x is 16. This is 2x squared minus 16. 7, no, minus 19x. So 16, 32, 44, 52. Yeah, okay. So see if you can get fast working these. This is a good level to work on. You will see problems like this. Okay, how fast can you do them? 2x squared minus 4. Minus 2. I like these. Yeah, so you're going to see something like that. And that's how far we're going to go. Oh, I said we were going to go multiply binomials, multiply polynomials, and I think that's going to be enough. This is going to be where we focus on for this week. Next week, we're going to get into these skills, okay? So work on those skills as well. So just get up to simplify by distributing this week. Get those skills in, and that's great. All right, everyone. Thanks so much for showing up for your learning, and I look forward to getting you into this course of just, arithmetic practice. This is arithmetic, this is just making sure your arithmetic is sharp in a variety of different situations. Keep on being awesome, and I'll see you in class and see you at the league. Bye for now, everybody.